Hello, in this video I want to touch on a few things in statcrunch that might make life a little easier this week. Um, I'm going to walk through some information about standard deviation, about binomial probability, and the central limit theorem. First of all, I'm just going to walk through again calculating standard deviation manually. These are our x values, 46825. Calculated the mean to be 25 divided by 5 is 5, and then we subtract the mean from each of our values. That gives us our deviation. Then we square those values, which is this last column here, and we add that up. The sum of the squares is 20. Now, if this is a sample, we divide by our sample size, which is 5. 1, 2, 3, 4, 5. We have 5 x values. So our sample size is 5. We subtract 1, which is 4. So we have 20 divided by 4 is 5. That's our variance, and we take the square root of it, which is 2.236. If, on the other hand, this is a population, we do not subtract 1 from the sample size. So our variance is just 20 divided by the sample size, which is 5, gives us 4. And the standard deviation is the square root of 4, which is 2. What I want to point out to you in statcrunch, let's get the standard deviation. These are our values right here, 46825. And we'll go to Stat, Summary Stats, Column, and we're using this right here. We'll go to what it defaults to, and you can see that the standard deviation is 2.236. statcrunch is defaulting to assuming that our data is a sample. So it is, in its calculation, subtracting 1 from the sample size to calculate the variance, taking the square root, and that gives us 2.236. Also, you can see the variance is 5. So statcrunch is assuming that our data is a sample. If, on the other hand, you want a population, we go through the same process, summary stats, column, we look for in our list, we have unadjusted variance and unadjusted standard deviation. That is what we would use for a population. So let's look at these two values, an unadjusted variance and standard deviation. Oops, I forgot to select my column, sorry. And we're going to calculate that, and now we can see as a population that our variance is 4, what we calculated, and our unadjusted standard deviation is 2. So if you need a population variance and standard deviation, you need to select the values that have this title, unadjusted variance and unadjusted standard deviation. Okay, the next thing I want to talk about over here is a binomial probability. So that's something that's in your material this week in Knowledge Path and in your reading. And this is the calculation you use to calculate a binomial probability. The important thing here is to be able to identify our n, our x, our p, and our q. N is the number of trials. X is how many we are asking about. P is a probability of success. And Q is a probability of failure. So we're going to go through it manually, and then we'll use statcrunch. 30% of working adults spend less than 15 minutes computing to and from work. You randomly select 6 adults. What is the probability that exactly 3 of them spend less than 15 minutes computing to and from work? So the number of trials we have are the number of adults that we are asking. So 6 is n. Our probability of success in this example is 30%. It is defined as spending less than 15 minutes commuting to and from work. That success could be defined as anything, but we are being told that the probability of that is 30%. So that is our probability of success, or P. Q is 1 minus that, so it's 70%, or 0.70. And X is how many we are asking about. That exactly 3 of them spend less than 15 minutes computing to and from work. So 3 is our X. So now I'm going to plug these values into this formula. We have n factorial, so that's right here, 6 factorial, divided by n minus x factorial. Well, n is 6, x is 3, 6 minus 3 is 3 factorial, and then we're multiplying it by x factorial, which is 3 factorial. All of that is being multiplied by the probability of success, which is 0.3 raised to the x power, so 0.30 raised to the third power, times probability of failure, which is 0.70, raised to the n minus x power, which happens to be 3. Obviously, that is not usually the case, so we're raising 0.70 to the third power. So I just use my calculator to calculate these values. 0.70 raised to the third power is 0.343. 0.30 raised to the third power is 0.027. 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1, which is 720. 3 factorial is 3 times 2 times 1, which is 6. So we have 6 times 6 in the denominator, which is 36. And then just using a calculator to do all of this, we come up with 0.18522. So I just went through this process and solved this problem manually, but now I want to show you how to do it using statcrunch. So we go to calculators, and you can see right here we have binomial, which is very handy. So we're going to select binomial, and we are just going to fill in these values. We have an n, which is 6. We've already defined what our values are. We have p, which is 0.30, 0.3, and we are looking for a probability that exactly 3. So we're not looking for less than, we are looking for that it is exactly 3. We'll type that in, select compute, and you can see we have 0.18522, which is what we got doing it manually. So much easier, much quicker using statcrunch for this. You can do between two numbers if you need to. Obviously here you can select whatever you need to select, greater than or equal to, etc., or equal to. So it's just a matter of interpreting the problem, determining what our values are, and then plugging them in over here. Okay, the last thing I want to touch on is the central limit theorem and finding probabilities. So first we'll walk through doing this manually, and then we will use statcrunch to do it. 500 adults are asked at what age they had their first job. The average age was 17. Here's our mean, with a standard deviation of 3. We're given the standard deviation. If 10 adults are chosen at random, what is the probability that the average age they had their first job was greater than 18? 18 is the x value. So the formula to calculate a z-score when we're using the central limit theorem is taking our x value, which is 18, right over here, subtracting the mean, and then we are dividing that by the standard. Now, if it wasn't the central limit theorem that we needed to use, we would just divide by the standard deviation, which is 3. But we're using the central limit theorem, so we're dividing it by 3 divided by the square root of the sample size. So 3 divided by the square root of 10, which is what we get right here if 10 adults are chosen at random. So then just using a calculator, we have 1 divided by 3, which is divided by the square root of 10, which is 3.162. 3 divided by 3.162 is 0.9488, so we have 1 divided by that. And doing that on my calculator, I got 1.05. What I've just done here is I've calculated the z-score by doing x minus the mean divided by standard deviation, which is divided by the square root of the sample size. So now that I have my z-score, I can go to that table that you would see in Knowledge Path, or actually can find anywhere in statistics. This is a table that we use for normal distribution using a z-score. The thing you have to remember about this table is that it's giving you the probability which is less than. So the probability associated with a z-score of 1.05, and we look to see where these two things intersect. Here's 1.05, and that gives us 0.8531. So the probability that the age of someone's first job The probability that's less than 18, because that's what this table always tells me, is less than, is 0.8531. But probabilities always sum to the number 1. So if less than 18 is 0.8531, to get greater than 18, we just subtract that from 1. And as you can see, we end up with 0.1469 or 15%. Or we can do this using our calculators, normal distribution, but we're using the central limit theorem. Again, we're going to type in our mean, which in this example is 17. Standard deviation, normally, if we weren't talking about the central limit theorem, we would just type in 3 here because that's the standard deviation. But what we want in our denominator is 3 divided by, you can SQRT, standing for square root, and then in parentheses our sample size, which is 10. And we're looking for an age greater than 18. So I'm going to change that to greater than. You can't see it, but it's just an option. I'm going to put in 18 here, compute, and I get 0.1459. I have a little different here, probably just doing to rounding that I did along the way. But if we round this to 2 decimal places, again, we have 0.15 or 15%. So I hope that helps going through this week's material. And as always, get in touch with me if you have any concerns.